In this lesson, we solved polynomial equations by using our good friend, the zero product property, hashtag ZPP, go tweet about it. The zero product property says that once a polynomial is factored and set equal to 0, we can then set each factor equal to 0 to solve for x. So number one, find all real solutions to the given equations. So our goal is make sure it's equal to 0, make sure it's factored, then apply the zero product property. So find all real solutions. So number one, it's set equal to 0, check. Is the polynomial factored? Well, it is. So what we do is we set each piece equal to 0. If x minus 5 equals 0, x equals 5. If 3x plus 2 equals 0, well, subtract 2, 3x equals negative 2, divide by 3 and get x equals negative 2/3. Or x plus 3 equals 0, and you get x equals negative 3. So our solutions to this equation are x equals 5, negative 2/3, or negative 3. For the simpler ones, maybe you just could look at it has a factor of x minus 5, which means it has a 0 of 5. It'd be good to this middle term, this middle factor here, to say, okay, minus 2 divided by 3, negative 2/3. But if you need to go through the steps, that's fine too. So this is literally applying the zero product property. That line right there is the ZPP, saying I'm going to set each factor equal to 0, then solve that nice linear equation. And the second one here, set equal to 0. It looks factored, but it needs to be factored completely. And looking at both of these binomials here, warning lights should be going off in your head. Warning, 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 that this is the difference of perfect squares. Both of them are. So I get 2x plus 3, 2x minus 3, x plus 4, x minus 4 equals 0. I'll start with the easy ones. If I have a factor of x plus 4, that means x equals negative 4 is a 0. And that means x equals 4 is a 0 from that second factor. You might write this as x equals plus or minus 4. It just means you have a positive 4 and you also have a negative 4. So that's setting each of those terms equal to 0. What if I set this term equal to 0? That's going to be 2x plus 3 equals 0. Subtract 3, 2x equals negative 3, divide by 2. I get negative 3 over 2. Similarly, for this factor here, the first thing I'm going to do is add 3 and then divide it by 2, so I get x equals 3/2. So my solutions are, the roots, the zeros of this polynomial are x equals plus or minus 3/2 or x equals plus or minus 4. There are 4 zeros, 4 minus 4, 3/2 and negative 3/2. But this is a simpler, lazy way to write our solutions out. So make sure it's set equal to 0, make sure you factored it completely, and then apply the zero product property by setting each factor equal to 0. 6x cubed minus 27x squared minus 15x. Well, it's a trinomial, but before I get into that, I'm going to say, wait a minute, there's a GCF I can take out here. I can definitely take out an x, because all of them have at least one factor of x. And then I'm also going to take out a 3, which leaves me with 2x squared minus 9x minus 5 equals 0. And then I need to factor this trinomial here. Well, how do I factor trinomials? I use the AC method. What multiplies to negative 10? A times c, that adds to negative 9. That's going to be 10 minus 1. So I get 2x squared, split up that middle term, I have my signs wrong here, minus 10 plus 1. So 2x minus 10, 2x squared minus 10x plus 1x, because I want those to add to negative 9, which those do minus 5. Then we group. I'm going to take out a 2x from the first two, mixing with x minus 5. So which means I need a factor of x minus 5 in the second group, which means I'm going to take out a 1. So my factors are x minus 5, 2x plus 1. Don't forget that 3x comes along for the ride, equals 0. It's set equal to 0. It's now factored completely, so we use the zero product property. 3x equals 0 means x equals 0. I get x equals 5 from that factor, and x equals, subtract 1, divide by 2. Subtract 1, divide by 2, x equals negative 1/2. Those are my 3 solutions to that polynomial equation there. And the last one here, I have x cubed plus 3x squared minus 4x equals 12. Well, we don't have a 12 product property, we have a 0 product property. So the first thing I'm going to have to do is move over that 12. I'm going to have to set this equation equal to 0 if I want to use the 0 product property. So I'm going to subtract over the 12, set it equal to 0. There's 4 terms, which means I'm automatically grouping. Take out an x squared from those first two, x plus 3. I need an x plus 3, and it looks like my GCF there is negative 4. So I've got x plus 3, a factor of x plus 3, that's my new GCF, times x squared minus 4. And my warning light's going off because that's the difference of perfect squares. And using the 0 product property, if I have a factor of x plus 3, x equals negative 3 is a 0, x equals positive 2, and x equals negative 2. Those are my solutions to that equation. Set it equal to 0, factor it using one of our million factoring strategies we have, then apply the 0 product property. Number 2, determine all real zeros and state their multiplicities. And state their multiplicity for the function below. Multiplicity just means how many times it happens. How many times the 0 happens. So we have p of x equals x squared minus 16 times x cubed plus 4x squared minus 16x minus 64. So to find those zeros, I'm going to set that equal to 0. And I'm going to say, wait a minute, x squared minus 16, that's the difference of perfect squares. And it looks like I'm going to have to do some grouping here, so I'm going to do some grouping off to the side here. From those first two terms, I can take out an x squared. I'm left with x plus 4. I need an x plus 4, so what am I taking out? It looks like I'm taking out a minus 16. So I've got x plus 4, x squared minus 16, which I can factor even more using the difference of perfect squares again, as in at plus 4 minus 4. So I've got x plus 4, x plus 4, x minus 4. So now that I factored it completely, I know my zeros are x equals negative 4, x equals 4, x equals negative 4, x equals negative 4, and x equals 4. So what are my zeros? My zeros are negative 4 and 4. Negative 4 has a multiplicity of, well, how many times did negative 4 happen? Multiplicity of 3. 4 has a multiplicity of 2. There were 2 of them, so that has a multiplicity of 2. That's a repeated 0. I have multiple of these zeros, so we call that the multiplicity. Another way you might have written this is probably as x plus 4 cubed, because there's 3 of them, times x minus 4 squared, because there's 2 of them. Doesn't matter, but the key thing is you have to understand multiplicities are how many times that 0 actually occurs. The zeros are still just negative 4 and 4. These multiplicity means they're repeated, which is going to have an effect on the graph of them when we graph polynomial functions in a couple lessons from now. And finally, number 3. Suppose that we know that x plus 2 is a factor of p of x. Find the other factors of p and use them to determine when p of x equals 0. So I want to know when p of x equals 0. Well, you're like, Coach, we've got 4 terms here, which means I'm grouping. If you try grouping, guess what? It doesn't work. This polynomial structure just doesn't allow us to group, which is why I told you x plus 2 is a factor. I told you x plus 2 is a factor, so we're going to divide. We're going to divide to find the other factors. I know x plus 2 is one of them. I got to find out what the other ones are. So you could do long division or reverse tabular here. I don't care what you choose, pick one. I think the last time I chose reverse tabular, which means this time for this video I will be doing some long division, just out of fairness. Okay, so how do I long divide? I say what times x is 4x cubed? Well, 4x squared times x is 4x cubed. Distribute that through, I get plus 8x squared. Change my signs to subtract. Those add to 0. I get 4x squared plus 5x minus 6, and we start the process over again. What times x is 4x squared? Well, 4x is. 4x times x is 4x squared. 4x times 2 is plus 8x. Change my signs to subtract. Those add to 0. I get negative 3x minus 6. We're almost there. Negative 3 times x is negative 3x. Negative 3 times 2 is negative 6, which means when I change my signs, I get a remainder of 0. So what this tells me is I can factor this expression, as I know x plus 2 is one of the factors. What's the other quadratic factor? Well, it's 4x squared plus 4x minus 3. It's using that relationship between multiplication and division. Well, this isn't factored completely because I've got this quadratic that I can factor here using the AC method. What multiplies to negative 12? That adds to 4. What multiplies to 4 times negative 3, negative 12? That adds to 4. Think about it, just don't stare. 1 and 12, no. 2 and 6, yes. 6 and negative 2 work. So I've got 4x squared plus 6x minus 2x. I'm splitting up that middle term, minus 3. Then we group. I'm taking out a 2x. I'm left with 2x plus 3, which means I'm taking out a negative 1 to get a 2x plus 3. So I get 2x plus 3 as my common factor, my new GCF, which leaves me with 2x minus 1. Don't forget that x plus 2 comes along for the ride, equals 0. Finally, I'm solving a polynomial equation. It's set equal to 0. I factored it completely, so now we get to use the zero product property, hashtag ZPP. I'll do the easy one first. We get x equals negative 2 because negative 2 plus 2 is 0. You might need to set each of these equal to 0, but first I'm going to subtract 3, pretend that's equal to 0, minus 3 divided by 2. X equals negative 3 halves. Add 1 divided by 2 is going to be x equals 1 half. Those are my three solutions to p of x equals 0. These are called the zeros of that polynomial. Those are the real zeros of that polynomial, and we'll investigate what these mean in future lessons. So hopefully this was a good review of Algebra 1. The beginning part, at least, is we set our polynomial equations equal to 0, we factor, then we use our friend the zero product property. Hopefully by now you've tweeted a couple times, hashtag ZPP. See you in the next video.